differentiation from first principles of a function of x given here, we are going to apply the formula here. When you are given the function of x, that is y equals 1 over x minus 1 here, and now differentiating from first principles, that means that f prime, the differential coefficient, I shall call it f prime x, is given by the limit when change in x approaches 0. We shall have the function of x plus change in x. This one subtract the function of x and then divide everything by change in x. Now let's see how to apply this one to get the differential coefficient. Now what we shall have here is I shall start by first of all working out this one here, and then later on I shall introduce the limit change in x approaches 0. Now let's proceed. So we have 1 over x minus 1, so this one becomes 1 over where there is x, you put the value x plus change in x, and this one subtract 1, and then minus 1 over x minus 1, and everything divided by change in x. Okay, now what is in the numerator? We can simplify what is in the numerator, and to simplify we are going to work it out just like working out fractions. And to work out fractions, I shall multiply the values of the denominators here, that is x plus change in x minus 1, and I multiply by x minus 1, and then at the numerator I shall cross multiply, so I shall have x minus 1 times 1, so I have x subtract 1 times 1, and then minus this 1 times x plus change in x, and then minus 1. And since I was dividing by change in x, that means I shall multiply by 1 over change in x. Now this one I can simplify further by opening the brackets in the numerator, and I shall have x minus 1 minus x minus change in x, and then plus 1, because negative and the negative becomes a positive, everything over x plus change in x minus 1, and multiply by x minus 1, and of course multiply by 1 over change in x. Okay, now from here we can go ahead and simplify further. I have x here minus x, that one goes because we shall have a 0. Also we have minus 1 plus 1 is a 0, and what is left is minus change in x. So the numerator we have minus change in x, everything over x plus change in x minus 1, and then multiply by x minus 1. So at this point you don't expand this value here, just leave it the way it is. Now multiply this one by 1 over a change in x, this value here, and you shall find that this one cancels out, so that in the numerator you shall have negative 1, everything over, and we have x plus change in x minus 1, x minus 1. Now at this juncture, remember I said I shall introduce the limit when change in x approaches 0. So this is now the right time to put in your limit. So you have limit when change in x approaches 0, and if change in x approaches 0, then it means wherever there is change in x, I put as 0, so that the final answer becomes -1 into x plus 0 minus 1, and then x minus 1. So x plus 0 minus 1 is just this one is just so this one simplifies to x minus 1 and x minus 1, and of course that is -1. So the final answer now becomes, remember when you multiply x minus 1 times x minus 1, you get x minus 1 squared, and that is -1. So the differential coefficient for y is equals to 1 over x minus 1 from first principles gives you -1 over x minus 1 squared. Thank you everyone for watching. Until next time, bye for now.